In order to launch the application, it's needed first to update the configuration files with the IP address of the host machine. One must also insert its own Telegram token. The single services can be launched independently from different terminal windows. In this demonstration, Docker containers have not been used, but they can be built by using the Docker file available in the project. We can see how the different microservices correctly register at the service catalog, when they can advertise their own endpoints in order to be reachable by other services. Having launched both catalogs, the MongoDB adapter and the Telegram bot, we can now move on to launching the weather station and the two strategies, the water delivery strategy and the lighting strategy. We can also see how the different microservices constantly update their information at the service catalog to prevent that their information is forgotten because too old. Before deploying the device connector, it is first needed to update its configuration with the correct IP addresses, as done before for the other microservices. In this example, the device connector is hosted on a Raspberry Pi, which is accessed through Secure Shell. This is the typical use case for our application, in which we suppose we have one Raspberry Pi per greenhouse. The device connector can now be launched, and we can see how it is able to register to the device catalog almost immediately. The Telegram bot is the main user interface for our application. The first operation that a user needs to perform is to register himself by providing his name, surname, and email address. Then, via the Telegram bot, the user is correctly added to the service catalog. Another type of operation which is available through the Telegram bot is to retrieve information about plants which are stored on the MongoDB database. Once the user has chosen his plant, he can now register his new greenhouse by providing the ID of the device he connected. The Telegram bot also stores the information of the user, which gets updated every time a new greenhouse is registered. The user can also request charts involving weather data, which is stored on the MongoDB database. These charts are provided through links which point to the dynamic dashboard of MongoDB. They are also updated regularly as new data arrives. One last task of the Telegram bot is to notify the user whenever the water tank is empty. The Telegram bot will also query the weather station to get information about precipitations in the next day and possibly suggest the user to fill his tank with rainwater. Here we can also see how the actuation messages are sent from the two strategies to the device connector over MQTT. MongoDB is a database service which we have used to store the static information about plants and the weather data, which instead gets updated daily. As said before, it also provides dashboards for data visualization. The weather station is a microservice which uses data coming from the sensors to provide both instantaneous weather prediction and rain forecast for the following day. Inside our application, it is used to predict rainfalls which can be exploited to fill the water tank. The machine learning technique on which it is based is a quadratic discriminant analysis, which in our case is able to achieve performances of up to 82% of accuracy. The model parameters are evaluated offline and are then loaded onto the weather station program to guarantee responsiveness.